Welcome back. Today we are going to learn acid-base titrations. We will know what are indicators. What is titration? Titration is a method in which we analyze that how you can determine the precise endpoint of a reaction and therefore the precise quantity of reactants in the titration flask. For titration, we use an instrument which is called burette. And burette is used to deliver the second reactant to the flask. This instrument on the left side you can see which has been fixed on clamp stand. An indicator or pH meter is used to detect the endpoint of the reaction. How we begin titration? Begin by preparing your burette by washing with soap and water. Then you have to rinse burette with tap water and then distilled water. And then finally rinsing with the titrant solution. You should check for air bubbles and leaks before you proceed for the titration. Be sure the tip of the burette is filled. Never dispense so that liquid is below the last calibration that you can read. You can see in the diagram, this is burette. When you begin, you have to note down initial volume. And before beginning a titration, you should always calculate the expected endpoint volume. This one is called Erlenmeyer flask. Prepare the solution to be analyzed by placing it in a clean conical flask or Erlenmeyer flask. You can use beaker as well, but generally Erlenmeyer flask is used for titration. If your sample is a solid, make sure it is completely dissolved. Then you have to add a couple of drops of an indicator. What are indicators? You know, indicators are those substances used to complete the titration so that you can notice the color change. Use the burette to deliver a stream of titrant, which is normally a base, to within a couple of milliliter of your expected endpoint. You will see the indicator change color when the titrant hits the solution in the flask, but the color change disappears when you stir. Approach the endpoint slowly and watch the color of your flask carefully. Use a wash bottle to rinse the sides of the flask and the tip of the burette to be sure all titrant is mixed in the flask. Make sure you know what the endpoint should look like. For phenolphthalein, generally used an indicator in schools and colleges labs, phenolphthalein is the indicator we used. For phenolphthalein, the endpoint is the first permanent pale pink, like you see in the diagram. The pale pink fades in 10 to 20 minutes. If you think you might have reached the endpoint, you can record the volume of the burette and add another partial drop. So record the volume, reading, and add another partial drops. Sometimes it's easier to tell when you have gone past the end point. If the flask looks like this is bright, you have gone too far. Acid-base indicators. What are some indicators we can use? An acid-base indicator is a weak acid or a weak base. The undissociated form of the indicator is a different color than the original form of the indicator. An indicator does not change color from pure acid to pure alkaline at a specific hydrogen ion concentration, but rather color change occurs over a range of hydrogen ion concentrations. This range is termed the color change interval. It is expressed as a pH range. First one, litmus. What is litmus? Litmus is a weak acid. It has a seriously complicated molecule which we will simplify to H litmus. The H is a proton which can be given away to something else, and the lit is the rest of the weak acid molecule. There will be an equilibrium state when this acid dissolves in water, taking the simplified version of this equilibrium. You can see in this equation litmus. In a reaction, you can see the arrows forward and backward, right side and left side. It means it's an reversible reactions. So hydrogen ions or proton ions has been given off and litmus remains there. The unionized litmus is red, whereas the ion is blue. You should not be confused with the equivalence point of a titration and end point. Indicator changes color at the end point. Equivalence point is the stoichiometric point where neutralization takes place. Ideally, the end point of the indicator and the stoichiometric equivalence point should coincide. There are some common indicators. Methyl violet, and you can see their colors at different pH range, at different pH level. Phenolphthalein is colorless until 7. It means phenolphthalein is colorless in acid, but it turns pink when it reaches to the pH of 8 to 10, you see. This is titration curve of a strong acid versus a strong base. Strong acid versus strong base. Titration curve for strong acid versus weak base. Strong acid versus weak base. Titration curves for weak acid versus strong base. acidic, basic, and neutral salt. If strong acid react with strong base, then salt is neutral. Is a strong acid and base is weak, salt is acidic. If weak acid and strong base, then salt is basic. After knowing these, let me give you these notes in a neat and clean writing. Salt is formed between the reaction of an acid and a base. Other product is water. A neutral salt is formed when a strong acid and a strong base is neutralized in the reaction. Weak acid and base react. The relative strength of the conjugate acid-base pair in the salt determines the pH of its solution. The salt or its solution so formed can be acidic, neutral, or basics, which I already gave you. Strong acid, strong base, neutral salt. Strong acid, weak base, acidic salt. Weak acid and strong base, basic salt. A salt formed between a strong acid and a weak base is an acid salt, for example, ammonium chloride or NH4Cl. A salt formed between a weak acid and a strong base is a basic salt, for example, sodium acetate. These salts are acidic or basic due to their acidic or basic ions, as shown in the previous slides. Now you can see this chart also, cations, anions. So this is Na. So Na can make a salt NaCl or NaClO4. Same way MgCl or MgClO4. So this salt explains itself, so I don't want to make more lines or mark these tables. You can take picture, you can memorize, you can write it down. Acidic salt, pH is always less than 7. Neutral salt, pH is always 7. We remember that 0 through 6.9 acid, 7 is neutral, 8 through 14 is the base. So if pH is 7, it means those salts are neutral. If pH is less than 7, then they are acidic. If pH is above 7, more than 7, greater than 7, then it's basic salt. That's all for the day. And in next lesson, we will be talking about titration and molarity problems. If you like this video, please share with others. If you haven't subscribed our channel yet, please do so now, so that you can receive new video notifications on time. And don't forget to click on the bell icon to receive the notification for the new lesson. Thank you so much.